Hello and welcome to the 3DuxDesign Penguin and Polar Bear Ski School tutorial. Just a quick introduction. My name is Marcy Klein. I'm one of the co-founders of 3DuxDesign. Needless to say, we love cardboard construction and play-based learning in the classroom. Here is a list of the materials if you are not using the 3Dux kit with this project. You can use this as a guide for the other materials that you most likely already have in your classroom that you can use for this project as well. And I will get started. For beginning, this project is geared towards students from kindergarten all the way up through 8th grade. It'll go over the engineering design process where students are making simple machines. Depending on the age group, you can incorporate circuits with LED lighting and motors. And there's lots of opportunity for learning basic physics concepts like early learners push and pull and the simple machines, but also there's plenty of room for much more complex physics concepts through the projects as well. And I'll go over which parts of the project are good for what as we go through it. Depending on the timeline and your classroom needs, we also have in the facilitator guide a lot of content to bring in lots of literacy and also some environmental studies through student research, creative writing, and through their presentations. We include resources for you on the impact of ski resorts on the environment. And there's also an opportunity to really think about designing solutions for current modern ski resort issues. So we can bring in that innovator and innovation mindset into the project as well. Of course, there's a ton of opportunity for hands-on fun. And I also include in this presentation other alternatives for extending the project through individual play or just concepts that you can incorporate into it for deeper learning. So it's broken down into 6 individual projects. It's scaffolded for kindergarten through 8th grade. 8th graders, the older students can go through all the projects. The earlier learners are probably going to do the no tech version, which I believe is projects 1, 2, and 3. But then they can also do some of the extensions, just we don't recommend the electric and motor kits for the youngest learners. The way you can run the project, however you want, you can have one class go through all of the individual activities, typically 1 or possibly even get through 2 per class session. Or you can do different grades or different groups of students doing different projects and then put the whole entire project together at the end for all of the students to enjoy. Each one of the projects goes through the 3DuxDesign version of the design thinking process or the engineering design process, where they identify the problem, they research and then design solutions, they build prototypes, and then they present. And based again on your timeline and your learning goals, you can have students go back and reimagine and refine their projects to improve them. Where you're going to find the project, it's on 3duxdesign.com. You go to the orange button called Learning Resources. Then you will find a range of different projects from design challenges all the way up through standards aligned lessons and big curriculum, where they're building an entire city, and then projects for after school programs. You're going to click on the basic design challenges, and then you're going to see a purple button that says holiday, seasonal, and more fun projects. And when you click on that, the tab will open up with the Penguin and Polar Bear Ski School. You will find 2 parts of the project. Well, there's actually 3 tabs, which I'll go over, but you'll see the project itself, and then you'll see also some opportunity for extensions that I'll go over with you as well. In the project, what you'll have is printable student booklets, which has all 6 of the challenges. Then you'll have separate sheets that you can print out where you can print out some characters for the students to cut out and build. And then we have some holiday specific seasonal content as well, if you want to dive into the holidays. We have a facilitator guide that goes through the process of each one of the individual projects, plus optional extensions. And we do include links to both written and some videos on ski slopes and especially with respect to the sustainability of ski slopes. So we'll dive into the individual projects. So challenge number 1 is to design the ski school. So in this case, your students are learning about, getting used to 3D hands-on modeling, either with 3Dux or with your own materials. And they're going through the engineering design process. Before you have them build the ski school, you should decide which challenges each group of students is doing, because the students, when they build the ski school, are going to need to know what else is going to happen. So for example, if they're doing projects number 2 and 3, which have to do with slopes and a pulley system, they're going to need to at least design their ski school with that in mind, knowing that they're going to need some type of ramp for the pulley system, stuff like that. So you're going to want to go through the project overview with them so that they know what the constraints are and what they need to include in their school. You can also take some time to discuss the importance. This is a ski school. It's a ski resort. They're designed to make money. And they want a good customer experience so people come back to the ski lodge over and over again. So the students are going to want to make sure that the ski school is alluring to customers. It looks pretty, that visitors will have a good experience. They have what they need. They need a bathroom, most likely. They might want food. They might want a store so that they can shop for equipment that they might have forgotten. Maybe they need a ski rental place. So that's where your students can have some fun coming up with a design to include everything that visitors might need. Maybe they need signs. Maybe they want an outdoor play area. I mean, the choice is really up to your students. That's where the creativity comes in. Students should list the essential structures that they need in their ski school before just going ahead and building it, so that they know how to account for all the things that they want to include. And then, of course, they're going to decorate it and construct it. Challenge number 2, different slopes for different folks. This is a slope and friction project. Essentially, your students are going to want to build 3 different pitched slopes and test the speed of the polar bear and the penguin on those slopes. So here we have the project challenge in the little student booklet, but we also have in the facilitator guide a link to a video that goes over slopes and friction for you. So you can share that with the students if you like. And then when it's time to incorporate the different slopes into the project, this is what your project might look like. So we're testing different slope heights and pitches. You'll see in the facilitator guide a few things to note. All of the slopes should end at the same distance from the ski school, so that it's actually the pitch that is different and not just the length of the ski slope. And the characters that are being tested should be the same material, the same shape, and the same weight, so that we don't have a confounding, variable. There needs to only be one variable at a time, which is the slope. Another thing that you can do with this project, let me see if it's on the next page. Yeah, is, testing different frictional surfaces. So your students can use different materials. They can use just cardboard for all 3 of the slopes, but then they can do 2 slopes at the same pitch, same length, but different surface materials, like covering one with tape or sandpaper even, to see how different frictional surfaces affect the speed as well. If you really want to dive into friction and use the scientific method, here's an opportunity to take like a little side journey into another project of ours, which is the 3Dux Winter Park Slopes project, where we have an entire project just based only on slopes and friction. And that itself includes a student booklet, an experiment where they're building a bigger slope, and then they're actually using the scientific method and changing one variable at a time and timing the effect of changing that variable on the speed. So that's one way to level up. Another way to level up this project, if you have a 3D printer and you want to include CAD and 3D printing into the project, rather than using cardboard slopes, your students can design different slopes so that you can use it for future projects. Every time you do this project, you can use those 3D printed slopes as well. So that would be a fun extension. And again, the students can do different pitches of their slope. They can put side rails on it so that the characters don't fall off the side. They can do different, materials. No, not different materials, but different way of laying out the printer material so that it's either smooth or more bumpy to test different frictional surfaces. So again, here's another opportunity to level up if you wanted to include more technology in the project. So challenge number 3, a tow rope and a wheel and axle. So here the story is that we want to build a tow rope to get the characters up to the top of the ski school or the roof of the school. The goal is for them to be standing in the end. So there's a few ways you can make your characters. First of all, you could just use figurines if you have those available. If you're using 3Dux materials, you're going to have the students cut out the little penguin or the polar bear and use a little piece of cardboard as a backer. And I have over here an example of a little character, and then we put a piece of cardboard behind the paper character, and then we can use the 3Dux 3-way connectors to have them stand up. So this way we have a perfectly stands up character. Mine in this case is a person, but your students can cut out the penguin and polar bear in the workbook and use those as their characters. We do have in the facilitator guide a link to a video tutorial. We have 2 different tutorials you can use to show students how to do this project. One is on wheel and axle, and the other one is on a pulley. They're going to use both. So this is more of a complex or a combining 2 simple circuits to make this project. And in the bottom right, I'll show you how it can look. So I'm using a straw and a string for my pulley. And then I'm making a slope, and then I'm going to turn the straw, and that will activate the pulley and get the polar bear to the top. Just to note, the wheel that I have in this image is actually kind of fake. It's more decorative. I'm actually cranking the straw, so that's not officially a wheel and axle. But if I were to tape the straw to the wheel, that would actually be a more accurate wheel and axle. And I'll show you that one more time so you can see what I'm talking about. So I'm just using the bent straw over here to turn, and the wheel is just turning because there's a little bit of friction. But your students can figure out how to make it so that the wheel is actually attached to the axle and functional rather than just decorative. Hopefully your students can get it in a way, design the project in a way so that when the characters get to this roof, they're actually still standing. So that's a little added challenge. if you want to add that to the project. So challenge number 4 is the Sasquatch Defense System. So this is a lever project with a catapult. On the left, you can see ways that you can build a catapult if you do not have 3Dux materials. Or you can use the 3Dux materials like the image on the right to create a pulley, not a pulley, a lever and a catapult system. We have a 3-minute video again so that your students can learn what's going on with a catapult and learn some vocabulary like the load, the force, and the fulcrum. So you can share that video with your students before doing the project. They can build their own little snow monster. I included some, some cutout monsters if they want to use those, or you can use, they can make their own monsters if they want. If you're using 3Dux materials, again, their monsters can stand up the same way that the animals stand up. If you don't have 3Dux materials, what you can do is when they cut out the characters, they can cut a slit at the bottom, bend one piece of the paper forward, one piece of the paper backward, and that will allow their characters to stand as well. Another option is to use paper clips to get them to stand up, or pipe cleaners. So there's lots of ways to get cardboard to stand up. Challenge number 5. Oh, going back to challenge number 4, sorry. So the goal is to have their monster in one location and design their catapult so that it consistently catapults the snowball to hit the snow monster. So they'll do that by adjusting the fulcrum height, the location of the fulcrum, and some other components of their lever. To optimize it to allow the catapult to be very consistent. They can also set up little X's on their table. So where does the catapult have to stand? Where does the snow monster have to stand to get a consistent function out of the catapult? In my picture, I have a little polar bear actually sitting on the catapult. But in the kit, there is a pom-pom, and I do recommend that the students use pom-poms. They're much softer. They're not going to hurt anybody. They don't go flying across the room, and they're not a ball that is going to bounce all over the place. So it makes for a really good snowball for this project. So moving to challenge number 5, the night skiing and smart lighting solutions. This is where your students are going to create a little circuit. I have in the facilitator guide a whole booklet on how to do circuits, as well as some images. So your students are basically making a paper circuit. The idea is to create an open circuit that can be closed by a character. And I will show you how that works. So on the right, you see the pathway, and you'll have access to this tutorial on how to make a closed circuit. So you see in the middle image on the left, well, here's image 1 is just drawn out. Image 2 is we're adding the negative side. Image 3, which I'm hiding, let me move myself over here. Image 3 is adding the battery. Image 4 is adding the positive side. Just of note, the longer prong on the LED light is the positive side. If you put it the wrong way, the light won't light up, essentially. And then in image number 5, I ripped the circuit. So it's now an open circuit. Then what you want to do is on your characters, you're going to put copper on their bottom, and that will allow the circuit to be completed when the character stands on the opening. And in this video, you'll see a version of this. So here it's an open circuit. And then I have metal copper on the bottom of my little character. And as he stands on the circuit, he closes the circuit. and that allows the light to go on. So that is essentially the type of circuit that your students are going to want to make. So that way, when the ski worker is there and running the slopes, that's the only time when the lights are on. So it helps save energy because there's no point in lighting the slopes if they're not open. Challenge number 6 is building a snow monster. Now you can do the snow monster as a part of this project, which will make the catapult activity really fun because now the snow monster is moving around. But you can also do it with any theme. So I'll show you in a minute. There's a reindeer version of this as well. But I'll walk you through the process over here of how you put your bot together. So you're basically making what I call a battery sandwich, and I'll show you a better version of this in the next slide. But in the end, if you get it right, as soon as you attach the battery, the little guy is going to move. So here is a Rudolph the Red-Nosed Reindeer version of the bot. The mechanics of the bot is exactly the same. It's just the decorative component of the bot. And in this case, I also show you how to create a parallel circuit with a light as well. So I'll run you through this. So here's your little Rudolph. Here, let me see if I can stop this. Hold on. Here we go. So here we start with adding, ignore the light lead, just look at the bottom lead, that's part of the motor. So we put one part of the lead down on two-sided sticky, then we add our battery, then we add the motor, and the orientation of the motor will greatly affect how the bot moves. Then we take another sticky with the other lead and we attach it. And once we do that, it should move. And what we did in this case, and I'll back up a little bit, is we added the LED lights. Now, keep in mind, the motor, if you put the positive and the negative the opposite direction, the motor will just spin the opposite way. But there's not, I mean, there is an anode and a cathode, obviously, but whether you go up and down with the positive and negative will not affect the ability for the bot to actually move. But the LED lights, you do have to have the anode, which is the negative, on the negative side of the battery, and the cathode on the positive side of the battery. So just keep in mind. But in this case, we have a parallel series because, and a parallel circuit, because the light is completely separate and it's done in parallel with the motor. So here we have again, so now you see the positive lead underneath the battery, and here on top is the negative lead. And then once we attach everything together, it will work, and the light is lighting up and the little guy is moving at the same time. So that's a little bit more complex, but your students can do the light and the motor at the same time if they want. So that's essentially the entire project. It's designed so that each part of the project can take one full class session if you wanted to. You can consolidate it a little bit if you like, or possibly for your older students, you can consolidate it. You don't have to do every part of the project. If you only have 2 weeks with your students, you can do 2 parts of the project. So each individual part of the project, other than building the ski lodge and challenge number 1, does not really add on to the other one. So you can pick any projects you want with any students. Ways to extend the project, and I left my O out of photo. I apologize. I'll fix that after this video. You can create presentations. So presentations can include photography, drawing, drafts, video, writing. You can do a live presentation. Have your students describe their projects, or maybe you want to make it a little bit more fun for the students and have them create a marketing advertisement for their school. So maybe they want to do a flyer and do, they can do it drawn. They can do it on Canva or use some video, photo editing technology to create their flyer, or they can create a video commercial. So the students can have a great time explaining their project, but also creating an advertisement for customers. If you want to extend it a little bit, you can design a resort for the entire ski school, or create an entire village around the ski school. So what else would people want in their ski school? Maybe they want a hotel, maybe they want ice skating, maybe they want childcare. So you could extend the project in that way and just build a bigger and bigger project. Or maybe you want to add some financial literacy into your project and have them come up with a business plan. They can research the costs to run a ski lodge. And then maybe they want to expand it for revenue during the summer and spring. What can they do with a ski slope when there's no skiing? And research that and come up with some plans. Or maybe they want to come up with ways to make skiing a more sustainable hobby for people. So there's just some ways that you can extend the project if you like. Of course, this is a video tutorial, so it's going to be hard for you to ask me anything here, but you can always reach out at 3DuxDesign and find us that way and ask any questions about the project. By the way, just going back to the presentations, if your students submit, or if you as the educator submit presentations, we love to include them in this 3DuxDesign student showcase. So your students' projects can be shared with the entire world. We'd love to share student work. If you're making any purchase for this project, you will want the 3Dux, the basic classroom kit on the upper left, plus the Build-A-Bot kit if you're going to be using the electronics for it. We also have a machine maker kit, which has the pipe cleaner, straw, string, pom-poms, and everything, the non-tech components that you might need. We have fun cardboard hacks. Here's great if you're not using 3Dux materials. Here are great ways to, create simple machines with other materials that you probably already have in your classroom. So if you're on our website, you can just search under hack and you'll find a page filled with different cardboard construction hacks. So that concludes the workshop. Thank you everyone for joining. Hope your students have a great, fun and educational experience with the Polar Bear and Penguin Ski School project. If you have ideas on new ways to expand the project, feel free, please reach out. We're always happy to include new activities in our list of project ideas. Thank you and enjoy.